Hi everybody, today I am going to teach you differentiable of functions with complex variables. So this is similar as continuity, little bit similar as continuity. So we have this equation f dash z naught limit z tends to z naught f z minus f z naught over z minus z naught. This is if z is different differentiable at z naught, we want to check whether this satisfied. So when we have to prove the differentiability by using epsilon delta definition, we use this equation, this part. If not, we use our normal equation for differentiability as limit delta z tends to 0 f z plus delta z minus f z over delta z. So here let take the function f z equals to z square. So f z plus delta z equals to z plus delta z square minus f z is z square over delta z. So you can expand this z square plus 2z times delta z plus delta z square minus z square. So z square cancels out and finally we get this part because delta z cancels out here and one delta z cancels out for this, and substitute delta z equal 0 for here, we finally get 2z. So if there is a function like fz equals z bar, so we already know that when z equals x plus iy, the bar of z equals to x minus iy. So delta z equals to delta x plus I delta y. So similar in continuity, we want to take these two limits. So delta z tends to 0, that means delta x tends to 0 and delta y tends to 0. So f z plus delta z, here substitute x plus delta y for z and delta x plus I delta y for delta z, and we can obtain this equation. So then limit delta x tends to 0, delta y tends to 0. So upper part is okay, delta z equals to delta x plus delta y. So the real part of this x plus delta x, then the imaginary part of this function is I y plus delta y. So this is the imaginary part, this is the real part. So this our function is z bar. So we need to take the bar of this whole function. So real part of this is x plus delta y minus I times imaginary part is y plus delta y and minus. So here f So this is the function x plus iy. Bar of x plus iy is x minus I. So you can simplify this. X cancels out and iy plus iy cancels out. Then we get limit delta x tends to 0, delta y tends to 0, delta x minus I delta y over delta x plus I delta y. So we already know how to evaluate this limit. First, take limit delta x tends to 0 as delta y is here. So delta x, when delta x equal to 0, we get minus 1, and limit delta y tends to 0. So here 0 and we get 1. So minus 1 and 1 are not equals. So this function is not differentiable. Thanks for watching. Goodbye.